Okay, today we're going to talk about prime factorization, and we're going to go over the notes pages. So if you have your notes in front of you, you should be in the fractions section on page F1, and we're going to start right at the top. Okay, and it has a blank blank is a whole number greater than 1 that has only two factors, 1 and itself, and that is actually a prime number. So I'm going to write in prime number right there. See if I can do this nice and small to fit the screen. Okay, good. A prime number is a whole number who has only two factors, 1 and itself. So an example of a prime number would be like 5, because all you could do is divide 5 by 5 and 1. Now the next one, we're going to talk about a composite number. So C-O-M-P-O-S-I-T-E, composite number. Sorry about the bad writing, but sometimes the stylus doesn't work very well. A composite number is a whole number greater than 1 that has more than two factors. So like the number 4. Okay, so 4 can be divided by 4 and 1, but it can also be divided by 2 and 2. So that makes it a composite number. Another example of a composite number would be like 6, because 6 is 6 and 1, but then it also has 2 and 3 make 6. Okay, and here's some examples down below. You have a prime number. Let's see if I can move this up together. Oh, look at that. I'm getting better on this thing. So examples of prime numbers. 5 again, like we said earlier, 5 and 1. 7 is also a prime number because only 7 and 1 can go in it. And 11 is another one. Okay, why don't you take a second and actually pause this for just a second. And on your notes, why don't you try to think of maybe the next two after 11. Okay, and write those down. If you want to think of 3, that'd be great too. Alright, so after 11, you should have 13. Okay, because 13 is only 13 and 1. Okay, 14 is not 1, 15 is not 1, 16 is not 1, 17 is 1, because that's only 17 times 1. And then finally, 19 is 19 times 1, and that's it. Okay, now composite numbers, there's a ton of composite numbers out there. The majority of them are. So we have 4 here because it's 2 and 2 and 4 and 1. 6 is 1 times 6 and 2 times 3. 9 is 1 times 9 and 3 times 3. You could do 8, you could do 10. Let's write 10 down here. 10, we have 10 times 1, and we have 2 times 5. And that's it for that one. 12 is actually completely a composite number because you have 1 times 12, you have 2 times 6, and you have 3 times 4. So you have 3 sets of numbers that can go into that one. Alright, so let's keep on moving along. So down here at the bottom, again, we're going to, what they want you to do here is just do the, list all the factors that make up this number. Okay, and then tell whether or not they are prime or composite. Alright, so I'll help you with the first one right here, 13. Okay, what numbers can make up 13? Just 1 times 13. Nothing else there, so that's going to be a prime number. Okay, now once you pause again, finish up the last 3, and then come back and keep playing it, and you can see if you did it right. Alright, so here, let's go to number 8. 8 can be broken into 1 times 8 and 2 times 4. Wow, I'm getting bad writing here. 2 times 4. And so that is a composite number. Okay, 19 is only 1 times 19. So that is a prime number. And finally, 21. 1 times 21, 3 times 7. So that is a composite number. Alright, so we got that first page done. Let's go ahead and turn over to the next page. Okay, so now we're on the next page. Let's look at the top and fill in some words here. Okay. So it says, you can break each composite number into a product. Okay, a product is the answer to a multiplication problem. Okay, so meaning you can multiply two numbers together. Okay, so you can break each composite number into a product of its prime factors. So a factor is a number that can go into another number, called prime factorization. Okay, and to do this we use the factor tree. Okay, some of you may have seen factor trees before, but basically what you're doing in a factor tree is you're just kind of breaking a number down into its parts. Okay, so let's take a look here, see if we can't break this down a little bit. Alright, so this is just an example of how to break down the number 32, okay, and the steps to it. You're going to break it down one step at a time by two numbers. So if you look, we have 32 right here. Okay, and 32 can be broken into, now you can do this a couple different ways because there's multiple ways to get to 32. But in this case, I did 2 and 16, and whenever you find a prime number, so 2 is a prime number, you go ahead and circle the prime number. Okay, so then 2 and 16 were broken out of it. Now 2 is done, so I circled it, but then 16 can be broken down again. So 16 got broken down into 2 times 8. And then 8 can be broken again, so it's 2 times 4, and 2 is circled. And then 4 breaks down into 2 times 2. Okay, and then when you're done, you're going to write out all the prime factors that you get. So here we had 2, we got 1 there, another one, another one, another one, and another one. So we wrote 2 times 2 times 2 times 2 times 2. And if you multiply those all back together, you should get the number you started with. Okay, now ultimately, the best way to write your answer is using exponents. Okay, and an exponent just tells you how many times you multiply a number times itself. So we have 2 times 2 times 2 times 2 times 2, and there's 5 of them. So we put 2 is the number we're multiplying, and we're going to multiply it by itself 5 times. So there's your exponent. You're done like that. Alright, so at the bottom, we have a couple U tries again. Now, in this case, we have the same number both times. So what I want you to do, I want you to take a second, and I want you to do this number both two different ways. There's actually a few different ways, but at least do two. And we'll start back, and we'll see if we can get it done together there. You check your work. All right. So let's look at 30. So let's try the first way. Let's do 3 times 10. Okay, and 3 is a prime number, so we're going to circle it. And then we can break 10 down into 2 and 5. And 2 is a prime number, and so is 5. So we're done. We have no more composite numbers, so we're done breaking it down. So our answer is going to be 2 times 3 times 5 equals 30. And if you multiply that back together, 2 times 3 is 6. 6 times 5 is 30. So we did it right. Now with the exponents, we don't have anything that has multiple times it's being multiplied together. So that's what you got. 2 times 3 times 5 is all you have. Okay, so let's try breaking down 30 again, but using a different way. So we did 3 times 10 last time. How about we do, let's do 6 times 5. So 6 and 5. And notice it doesn't matter which way I went. So the prime number in this case is the 5, and it was second. It didn't matter. All right, and then let's break down the 6 into 2 times 3, and those are both prime numbers. Okay, and we're done, and we have 2 times 3 times 5 again, which gives us 30. We did it, so that's perfect. If you have any more questions, feel free to ask me later.